We are group 2 from Professor Perger's Engineering 131 afternoon class, and this is our presentation for the Kimberly-Clark project. My name is Dominic Yankas.
I'm Drew Gaston. And my name is Colby Lee.
Our problem was really noticed once we saw that current waste collection does not discriminate between types of waste, which largely eliminated the possibility of composting the paper towels. So we set out to fix that. The end users are bathroom patrons and sanitation staff, and the stakeholders are Kimberly-Clark themselves.
For our trash can, we came up with several criteria and constraints. For the criteria, we wanted to be affordable, durable, simple, energy efficient, and have little to no user change. For constraints, we wanted to make the trash can be produced in the least amount of time as possible, be as safe as possible, have a less than 1% contamination rate between trash and paper towels, and fit inside a public bathroom.
What you can see right now is a few of our concept ideas beginning the design process. Some of these ideas had to be thrown out right away, essentially because they violated our key criteria. One of them is the incinerator device, which aimed to destroy undesirable waste so that it wouldn't be contaminated. But this would violate our safety criteria. Another design idea that we had to remove fairly quickly was one based off of an electromagnet, which violated our principles on cost, as the amount of power to make the magnet run to actually repel any paper towel would be extraordinary. Moving on to our top 3 ideas, we have the fan can, the switch, and the pitcher plant pipe.
Starting with the switch, we decided to use a light sensor and a flashlight to detect the amount of light that there was inside of the trash can. If an object passed through the light sensor, the number on the digital clock would begin to decrease, which would signify an object passing through. Using this sensor, we decided to test several different sizes of paper towels and waste to see if the light sensor could actually detect anything. Unfortunately, the results were not very accurate, and we could not continue with this prototype.
Our next design, the fan can, used a chopper-like mechanism that was aided by a fan. On the prototype, it was a paper towel, but we hope to swap that out in future iterations of this design. The partition would ideally allow for weight-based sorting, wherein a heavier object would pass right through the partition, as it wouldn't be very hard for a heavy object to go through it. And lighter objects like paper towels would ideally roll off the side of it into the sorting system.
Of our final 3, we have the pitcher plant. This idea was based off of in nature, where a pitcher plant excretes a smell that attracts insects so that they can be devoured. Our device would excrete a pleasant smell so that bathroom patrons would be attracted to the trash can of desire and hopefully only throw away their paper towels, which have no smell at all, rather than their other bathroom garbage. However, this subliminal change is not likely to be as effective as we thought.
According to our calculations based on a weighted design matrix, wherein we weighed all of our criteria and constraints, we chose the fan can based on the fact that it was largely able to correctly place trash and correctly place the paper towels where they needed to be. Moving forward, we're going to use a different lightweight material, which will replace the paper towel used in the prototype and add walls on all 4 sides so that it will be more effective.